All right, so once you're into the VM, so we have pre-packaged the ArcGIS Pro, that is the Esri software that we are talking about. So if you double click on it, it will open, and then we have to actually authorize it for the license, because by default you have to buy a license, but for this conference only we got a pre-authorized license, so we have to authorize it. So anyone got any problem reaching until here? Okay. Okay, sure, sure. Okay, so you see this ArcGIS Pro, that icon, you have to double click on that and then it will launch this. So this is the GIS software that we are talking about, provided by Esri, that we'll be using for this tutorial. So now so if you go on top, you should choose single use license. Single use or user, I have trouble seeing it. Okay, single use license. Then you have to click on authorize. So once you click on authorize, so you have to choose the last option, which is I have the authorization, and browse. Yep. Okay, so I'll go to the next step then. I think most of the guys are ready. So this is the file, you have to double click and then just next. So it should be the first option, authorize with Esri, and just follow the next instructions. So it will now try to authorize with their licensing server. So once we are authorized, actually it shows the date here then, like which date it expires. And it will say like it is going to expire in next 3 days. So if you're into this screen, then that means everything is working fine. And we can just click and open a blank map. All right, so this is our ArcGIS Pro. So now before getting into the next one, for Mary's tutorial, you have to use the Jupyter notebook that you want to execute the commands. So what you need to do, you see that icon here, if you right click on it and run as administrator, should launch the Jupyter notebooks. By default it will launch in Internet Explorer. If you're okay with that, use it, or if you want to change it, like want to use Firefox or something, you can copy this whole URL and paste it in Firefox, just in case. I'm showing both the options. but either of them should be good.
All right, so I have to say, as a data scientist at Microsoft, we have to dog food these things, and so I'd be using this if I had a choice or not. But this product is really excellent. Like it works every time, which is necessary in my case because, I need to create one of these VMs typically every day, work through something, and then shut it down again. Double check that tutorials that I make and solutions for clients work for them out of the box. So to be able to create one of these things new and have it work the same way every time, that's really awesome. And to not sit there waiting for Anaconda to install, Pandas to install, it makes a big difference in my life. So I know you're getting a particular experience of having this VM created for you in advance. I just want to make sure you don't feel like this is something that is unobtainable for you now when you go home. So I just want to show you, this is Azure Portal. It's our GUI interface for creating resources. We also have a command line interface. But if you wanted to create one of these GeoAI DS VMs, it's fairly simple. We search for this thing, it pops up, tells you a little bit about what you're going to get. You click create. It's going to ask you for some information. So I'm not going to go through all of it here, but it'll ask you what credentials you want to assign to this thing in your account. It'll eventually ask you what type of SKU you want to use. So how many GPUs do you want? What type of GPUs? Well, we cheaped out a little, folks. We got you the K80, single GPU machines for this tutorial, but we make them up to 1, 2, or 4 K80s. We also do 1, 2, or 4 V100s, P100s. So you have some GPU choices and kind of a range of different speed levels that you can do the trade-off that you want for speed. And this same VM, the same image, the same hardware, is what you would use if you scale up later with batch AI to a GPU cluster. So you're not going to have to worry about, is the image different? Is it a different, CUDA or cuDNN version? Now my Docker container is not going to work. No, there's no problem there. Now, most of these are available in Ubuntu and Windows, but this particular GeoAI data science VM is not, and that's because of the reliance on Esri's program here, ArcGIS Pro. But in general, you get a very similar functionality switching between those two operating systems. So just wanted to point that out. That's really handy. Okay, so I'm going to go ahead and connect. My connection experience might look a little bit different from yours. I've created this one in my own account. Okay. Bear with me here. And I'm going to launch Jupyter Notebook just like you did. And then we're going to take a look at where these notebooks are stored. What you may be noticing already if you've loaded Jupyter Notebooks on your own machine is that it will have dumped you into the user directory for your login. So you'll be looking at things like documents, downloads, the folders that if you're a Windows user might seem familiar from that users directory. So this might take just a little moment to get rolling here. There we go. Okay, so here it is on my machine. I'm going to make extensive use of this zoom tool to show you where I'm going. But you can see that there's a folder in there that is not normal for a user directory like this, and that is the notebooks folder. So if you want to navigate in there, what you're going to see is that we preloaded this thing with a bunch of tutorials, just like Bonnie told you. Right, and so these things are not specific to geospatial data science, and that's because the GeoAI DSVM is just an extension built out of a more general product, data science virtual machine. So you'll see that we have installed, TensorFlow, CNTK, Chainer, we have Spark. There are all sorts of things already available here, and that's designed to save you the time of having to install it. We also, so in particular, I think with the Ubuntu DSVM, it's a little bit easier. We have Docker with there's some limitations on the Windows Docker install. Unfortunately, less support for Linux VMs on Docker here, but in general, you'd be able to bring in whatever you want and run it. Okay. So you might see a folder called GeoBooks. Has anyone seen that on their machine? Okay, great. This happens to me every time. I don't know why this happens. But so I see that folder is not present for me, and if that's the same issue for you, what I'm going to go ahead and do is go to my repo and download all of my notebooks to prove to you that they are in fact there. So go to my favorite search engine. Sorry, Bing. Okay, and so then what we call this the pixel level land classification repo is in our Azure account. And I'll make sure you get a hold of this URL later if it's not displaying super clearly now, but so this will be in our slides too with a link. So this repo is actually what we have going on with the Geo AI DSVM is that all of those basically the notebooks are being downloaded directly from this repo, so the latest version onto your machine as it's provisioned. So you're getting the latest copy, which I'm going to now download myself. Okay.
Maybe you want to wait for a couple of minutes?
Okay.
Just making sure everyone is on this page.
Oh yeah, sure. Sorry. Yeah. So you guys already have the notebooks installed. So rather than wait, what I'm going to do is I'm going to install them on my machine. Yeah. I know. Gopi and I have had this conversation before about my stuff not getting downloaded here. Okay. Let's see. They seem to be the only person affected. Also installed by default is Git, so that's handy. Oh. Huh. I'll copy that for some reason. Okay. Okay, so in your case, you'll see a folder called GeoBooks. In my case, I have a folder called Pixel Level Land Classification. But regardless, if you navigate in, you should wind up finding a folder that has these 4 notebooks: Intro to Pixel Level Land Classification, Train a Land Classification Model from Scratch, Apply Trained Model to New Data, and Apply Trained Model to ArcGIS Pro. Now I thought I would have the directory names on here, so I haven't memorized them. But does anyone remember exactly what that was? Were you able to navigate into it and find what that? Yeah. Okay. Okay. GeoBooks, AI for Earth, and then you'll find. Yeah. Okay. Beautiful. Thanks. And there you'll see there's some other examples there as well. Okay. So how are we doing? Are we on the same page? Okay. Oh yeah. Okay. Quick question. Yeah.
Are you downloading anything from GitHub?
Only me. Only because my GeoBooks folder is never there.
So
that one.
GeoBooks.
Yeah. Okay. Alrighty.
Yeah,
Okay.
Oh, okay. We already have it.
Yeah. Exactly.
So
Yeah. This is the.
everything you need to
Run, thank you.
Okay. Okay, sorry about that. So anyway, so we've got these 4. You can see they're numbered. I'm going to go ahead and click on the first one here. This is an intro notebook. Doesn't actually have any runnable code cells, but I'll tell you a little bit about the demo that we're about to go through. So as I scroll down here, what you're going to see is some sample input and output from these models. So we're going to train very briefly because, I think it would be a dull experience to train for several epochs here, especially with just one GPU on this VM. So the type of training data that we have available are in these first 2 rows of this image in the notebook. We have the aerial image. You might see it looks a little bit dulled, almost white. That's typical of images from this NAPE imagery program because they have this near infrared 4th channel that sometimes gets treated as a transparency channel. So the images might look a little bit, whitewashed. But you can see also the ground truth labels that Chesapeake provided, and hopefully you'll believe that they're fairly consistent. If you take a look down in the next few rows, what you'll see is what our model is going to look like with its predictions after 1 epoch of training. That's the amount we're going to do as we sit here today. And then after 250 epochs with our full data set. So we're going to download a small portion of the training data to your local machine to do this example. If we used all of the available training data from Chesapeake Conservancy and trained for 250 epochs, we'd be looking at something as crisp as what you see at right. And you can see that even after 1 epoch of training, this model is starting to pick up on features that were actually missed even in the ground truth labels. So there's maybe a moss-covered lake up here. I don't know, this is going to appear clearly on your screen, but maybe on your own laptop you'll see it, that is in fact a lake, but was missing from the original labels. So it's starting to pick up on real, some actual improvements on the original training labels. So that's what you can expect to get as a result out today. Once we have trained these models, what we're going to do is actually deploy them inside of ArcGIS Pro, which is that program you just installed a license for. So when we do that, what we're going to be able to do is navigate around and see those labels and their corresponding images as we move around in real time. And that's one of the major advantages of ArcGIS Pro for end users, is the ability to navigate to a position of interest and look at all of those labels. I will be showing two things. One of them is just the hard classification, what is the most probable label for each pixel. That's at bottom right. And we also get some idea of where the model is uncertain by blending together those sort of colorized labels based on the probability that the model assigns to them. So we get a couple different views here. So today we are giving you license to a license from Esri in order to maybe save some time, prevent you from having to provide your personal information. But other ways that you could launch this ArcGIS Pro program, of course, you could pay money for the license. You can also sign up for a trial membership. And this is actually handy. You can do this at home as well. So you can this will help you download the bits locally, and you can try them out on your own computer if you want. It's a very cool program, which we're not going to go into the depths of what it's capable of doing today. But if you do want to sign up for a license, you can still go through these examples. With that trial membership, you would just wind up logging in on the login screen for ArcGIS Pro, and you wouldn't have to find this file locally or any of what you just went through. So just a heads up, it can be simpler than that. Okay, now before we launch the second notebook, what I'm going to ask you to do is if you have ArcGIS Pro open right now, could you go ahead and close that for me? There's a reason for that. So ArcGIS Pro is very good at locking the GPU for its own purposes. It's able to use that graphic acceleration, which is wonderful. But we don't want it right now because we want to have that GPU all to ourselves. So let's go ahead and launch that second notebook. Now this is also a bit of a fudge because this notebook is not where we're going to run our training script, but you can see it. We've provided some detail if you had more time to go through and read. You have its own explanation of what's going on here, but I'm going to give you the verbal version. So if you run this first code cell, how many folks have used Jupyter Notebook before? Majority? Okay. If you haven't, don't worry about it. There's a simple trick. So when you see these code cells that look a little bit more like a Courier New type face type thing, if you click in them and press Control-Enter, or there's also like a play button up here, it will start running that code in place. And so that's the advantage of the notebook, is that you then have the description around it to help explain what's happening. So you can see this thing starts with an exclamation point. It's actually running a command line utility that came pre-installed on the Data Science Virtual Machine. It's called AZCopy. And this utility is used to help copy things off of Azure storage accounts locally or between storage accounts, however you like. So what this is doing is it's taking down all of the supporting files, the large data files that we didn't want to just preload onto your VM in advance if you weren't going to use them. And that includes our training and evaluation data, the scripts, and a sample project for ArcGIS Pro. So this is going to run a minute, but you'll see these commands are kind of easy to construct. We've written we have a central repository where we update with the latest versions of this code, and we have a key to allow access, and we're downloading. You can see that actually the destination where we're downloading things is the D: drive. So these data science virtual machines are created with a relatively small permanent disk, but also a large scratch disk. So if depending on the number of GPUs you have, I think that scales the size of the data set that you could store there. So let's go take a look. Okay, so on this machine, with this single GPU, they've given us 340 gigs of space on this scratch disk. Important to know about the scratch disk is if we turn this VM off and turn it back on again, that disk might be wiped, so it might be empty. But this is still handy since we're just copying this down locally, we could do that again if we needed to. Okay, so I'm going to navigate in there and just show you what's coming through. I can see this is just finished. There's a warning about the data loss if it's restarted. Okay, so you can see, we've downloaded training and evaluation data. We have an ArcGIS Pro folder that contains a sample project we'll use later. We have actually a pre-created trained model right now that we've copied down, and we're also going to copy in we're going to create rather a new trained model as you run your training script. Okay. And then we have some wheels that I think are not currently in use. So we're going to take a look back at the scripts later to tell you what the scripts are doing. But first I want to get that running since it takes a little while. And maybe once it's running, we'll give you a little bio break or something as we come back in. Okay, so how many folks have this transfer finished? Anybody not finished, actually? I should ask that. Okay, we got a few going. Okay, so no worries. I'll take that opportunity then to just explore a little bit more what this training data looks like. So we have these, we navigate into that folder, or you can just look at mine for the time being, there's no need to do it yourself. You'll see that we have these relatively large TIFF files. So the ones, they come in pairs. So the ones that end in NAPE are larger. This is because they have really fine-grained, so they have more possible RGB values. So they don't compress as well. But these are those 4-channel red, green, blue, and near-infrared satellite images. And they're paired with the labeled land covers. So these images actually have the same dimensions, even though they're very different in size, although one of them has 4 channels and the other only 1. So if you try to load these things, you might experience some difficulty due to their size. And that's one of the things that we have to worry about during training, is how to do that in an efficient way. But if you were able to load them, you would probably also see that they still are difficult to visualize, because first the land cover is just an index label for describing whether it's water, trees, grass, or developed or impervious land. We also have a no data label, which is very common in the GIS community, to have some places where you just don't have any information. And I mentioned the issues with visualizing the transparent, the near-infrared channel showing up as transparency. So these things are not very easy to take a close look at, unfortunately. But we'll show you some sample code snippets later in these notebooks where we actually open them up and look at just a small fraction of them at once. Okay. How about now? Are these transfers wrapping up? Anyone left? I don't want anyone to feel. Okay, I'm sorry. Okay.
It didn't say done, so.
Okay, we can. Yeah. Okay. All right, we'll move on, but I don't think you'll miss out on anything as long as you're checking out what we're showing here. So later in this notebook it describes, well, if you're going to run this thing locally, you're going to have to install some more Python packages. And this, I think, really highlights some of the advantages of the data science virtual machine in general, is getting packages installed that you wouldn't want to have to deal with yourself. In the geospatial community especially, there are these libraries that are I think they're a little bit easier on Linux and Mac, but on Windows it's just hellacious to install these things. And Bonnie, I think personally did all that work, so thank you, Bonnie, for doing that, for all of us. Anyway, so these things are pre-installed. It's not just the package, but also the library behind them, backing them. If you do need to do this yourself on Windows, there's a guy named Christoph Golke who runs like a third-party Python wheel website. You might have used it in the past. That's kind of that's very handy, but we're not able to redistribute it, unfortunately. Okay, so you might not recognize these package names, but they'd be useful in that geospatial community. And they come pre-installed. Okay, so to get started with the training, we're going to take a look first of all to show you what the baseline looks like for your GPU. And I know some of you might be more familiar than others. Don't worry. But we're going to use a command line program utility called NVIDIA SMI that is installed along with our NVIDIA GPU drivers. We're just going to run this code cell. So again, Control Enter or the Run button. This will not work if you're still downloading, by the way. You could just get queued up to be run when your download finishes. But you could run it from a command line prompt if you wanted to. And so what I'm seeing on this screen, first of all, I have sort of a GPU ID. I only have one GPU here, so ID 0. And I'm seeing that it's relatively cold, 52 degrees Celsius in some, East US data center somewhere. And it hasn't been using a lot of power recently. And in fact, it has no memory usage right now, and it has no utilization right now because it's not being used by any program. There are no processes that have attached to this GPU. Okay, so what we want to see is that when we launch this training program, that GPU does come into use. And one of the things we can use to check on how well we're doing with our code, with keeping our GPU busy, is a utility like this to say what is the average GPU utilization. Is it close to 100 like we would hope? If it's not, that's a sign that maybe we need to move our data somewhere where we're getting a faster transfer, or find some more efficient way of using that data. Okay. So this tutorial is designed to be used with 1, 2, or 4 GPUs. So we have a command here that has a little variable in it called num GPUs. I'm just going to have you go in. Oh, sorry, let me do my little zoom guy here. Oh, that was not it. Control 4, I think. Okay. Alrighty, there. So this num GPUs, I'm going to come in, I'm going to delete it, I'm going to type in 1. Okay, what is this command? This command MPI exec is what we would use to launch a distributed training process that used multiple GPUs and help them communicate with each other. In that sense, it's a lot like Horovod. For other, deep learning frameworks, you might be using a different system. So for TensorFlow, for example, you'd be starting different processes for, for the parameter servers for the workers and master. But this is the trick for us. You'd be using basically exactly the same program as a utility to launch, a Horovod distributed training job. And what's it going to do? Well, it's going to launch Python. It's going to go to that training script that I promised you I'd describe later, and it's going to bring in training data from a certain directory, save the output model to another directory, and it's only going to train for one epoch. And even so, we expect this to take about 20 minutes, maybe a little bit longer in some cases, right? Just because of the size of the epoch that we chose. I guess we could have fudged with that, but I wanted to make sure we got a model that had just a acceptable result. So what I'm going to do then is I'm going to highlight all this and copy it, and my end goal is to paste it into a command prompt. So I'm going to pop back out of this zoom and say, just want go ahead and launch a command prompt. If you're not familiar, you can click on this Windows icon and press CMD. You get command prompt option. Okay, and just paste that little bugger in there. All right. Okay, so you're going to see nothing happen, probably, right? Is that where you are? Okay, so we expect this to take a moment to launch up. Eventually, you'll see a few lines, so I'll zoom in on a few of them here. Not much more will happen for me, I think. So in this case, I'm seeing messages that look like, I only have one node communicating. That's because I'm launching this with a distributed training utility, but I only have one GPU. So they're not communicating with itself, I guess. And it did find my GPU, and it's using that as the device. That's a good sign. If you don't see that, something is wrong with your install. But that's another thing you never have to think about if you use a data science virtual machine, is making sure that NVIDIA and all this are configured correctly. That'll be done by default. And so you can see it's using a math library that I hoped, and it's started to launch. Now, because of how we set the epoch sizes in terms of number of samples, you're actually not going to see any more input out of this program until it's done. If you were training for multiple epochs, you might get something a little bit more reassuring, like a loss that decreases over time, and classification error that decreases over time. But you're not going to see that output on the screen for a while. So this thing is just going to digest. So what I think might be a good idea is maybe we take a break now for 10 minutes and folks can use the restroom or whatever. We'll let this go on. And then I'm going to highlight a few things in the script while we wait for all of the training to totally finish. And then we'll be ready to move on. So if you exit on your left and go straight down the hallway there, I think that's the fastest way to the restrooms. Feel free to ask questions if you have any.
Okay, so I just want to be clear. So if I sign up for some account, I spin up the resource agency.
Yeah.
The resources, maybe, I don't know, however they're being charged.
Yeah.
They charge, some charge, you sign up, use is $6 a month. Some resource fee is actual use. So if I do stop, that means that account, I'm not doing anything. Next time I run, I just say, bring it back up, and I say, run the resource A that charged by the month. Will that stop charging me for the duration that I say stop?
That's right. No, so there's some caveats here. So I just want to make sure you're fully aware. So there's a pricing calculator that will help you run through. So some of these things are charged in different ways as you're picking up. Let me see if I can't find that Azure calculator. Yeah, here we go. So you'd come through and you'd pick up whatever. If it's a virtual machine, you'd pull up that little thing. So I think I've done this before for the virtual machine, and I can say exactly what size it was. And figure out, for the number of hours that I ran it, so I can do this by hours, how much I'm going to get charged. There's some other types of resources too, like storage accounts. that don't really have a corresponding stop option, and they're not charged by the hour. So in this case, they might be charged instead by the number of I/O operations, the number of times you try to read, or things like maybe the total file size that you download. I think is the direction to do it. Yeah. Yeah.
Yeah, I just,
Yeah.
what-
Yeah, it's even with this tool, it is still complicated, but I think they try to make it. Considering how complicated it actually is, they do a decent job making it transparent. Yeah, that's helpful. And yeah, you can. I mean, to be honest, when I'm playing around with things, I create them and delete them again. As soon as I'm done, right? There isn't a whole large advantage to keeping the thing around because the setup is so fast and automated. So, like with these DSVMs, all that is installed. There's really no reason for me to keep the same VM around.
right, wow.
Yeah, just make a new one later.
Well,
Yeah.
that part is not an issue.
Okay, yeah,
The
yeah.
part that, okay, I want to do certain use cases.
Yeah, exactly.
Right?
Yeah,
I want to load, well, I might not get all the data, all the stuff.
that's true. That's true.
One day,
Yeah.
I cannot get it, I wait for somebody to give me the information that could be 2 weeks from now.
Yeah, no, I totally understood, and that would be an ideal case for stopping and starting again.
Okay.
Yeah, absolutely.
The stop means you
Yeah.
At the $730, this is the GPU machine though. If it is not GPU, it will not machine.
Yeah, so so I think it was the DS series, and again, there are guides to what all these different sizes are. So it's a bit
shows
painful
the
to view,
charges
but
also on the right side, like how many dollars.
How did you get to this page?
oh, I'm sorry. This pricing calculator is
Yeah, I got there.
yeah, let me see. Oh,
But then,
there. Okay, and then at the top it'll give you some options for the things, types of resources. So if you click on virtual machines, it'll pop up down below, a place where you can enter in info on the virtual machine.
So is it just, to run this stuff, is it, I would assume you need more than one VM, or one VM with all the different, Spark, or Jupyter, or whatever else.
So this DSVM that we are giving.
Well, I know this is,
Yeah.
This has
Okay, yeah.
okay, but when I can, it said DSVM selection on here?
Yeah, so this virtual machine, we actually don't charge anything for the image. We
Yeah.
only charge for the compute. So you get all of that installed for free,
But-
as if it were a bare bones machine. It'd be the same
But
price.
how do I pick
Yeah.
the DSVM on here?
Well, since there's no pricing difference, you don't specify it in this
It's the same
calculator.
price.
Yeah,
Oh,
So
it's the same. Yeah, it's a
for-
different
for
image,
this,
but
we
it's
are
the same
not
price.
charging anything.
Yeah.
Right,
Just you have to pay
Yeah.
for the compute, like regular VM.
okay.
Yeah.
But if you go to create a VM, there it will say like what. So he's asking like how would I create a DSVM?
Oh, okay, yeah, yeah. So
I think you mentioned that before, sort of really quick, right?
yeah, no, I didn't do a
But
great
it-
job
it's
showing
also-
what that looks like. So I'll show you here what because we got a few minutes I think before that break is officially over. Okay, so say I want to create a new VM. It's going to ask me the name of the VM. I'm going to have to specify some kind of long credentials, or it'll get mad at me. You can also use a secure shell, I think, for some VM types. Okay, the location where I create it can matter because some GPU types are not available everywhere, but this East US one has all of them. Okay, so here on the next page I'm being asked what size of machine I want. And now there are guides, so these acronyms are not super informative. But if I,
And this
I
was the
can,
price
yeah.
on the
So,
page.
so if I know I want, okay, all these types. These 6.
So we need about, so
GPU.
when we create, what we'll be learning, we need about,
So we used an NC6, which is a single GPU, and it's a K80 GPU. So it'll be on this list somewhere. You can see there are all these more recent versions as well. But yeah, yes, I click this guy. Okay, and so that's the default option. I think it selects for you too, depending on what region you create in, I'm sure. And then so it'll summarize what it's going to give me, and then I can click buy next. I think it just checks that all my choices match, so that's this validation.
so the buy will tell me how much,
Well, doesn't appear it does. I wonder if it shows up on the SKU page. It might just be on that
Yeah, it
calculator.
shows the price here,
Oh, okay, yeah.
the right column.
Oh, okay, yep. So let me, it's going to load here, but let me,
So yeah, the dollar amount on the right column.
yeah, here we go.
okay, that's,
This is per month now, so yeah.
that's, 806.
Exactly. It works out to about $1 an hour, I think.
Okay, so, so if I
Okay,
Yeah.
yeah, exactly. If you do a stop, you're not paying while it's stopped. So you're only paying when it's running.
Okay,
Yeah.
so let's just say I spin this up.
Mhm.
I have 2 hours working on this project, it's cranking along.
Yeah.
Phone ring, I need to
Yeah.
do something else.
Yeah.
Yeah.
Right? I stop.
Yeah.
Right?
Yeah.
A week later, because I need to travel to somewhere.
Oh, sure, sure.
I
Yeah.
said resume and everything will be there.
That's right. Except anything on that scratch disk, the disk that empties when it restarts. There's a scratch disk which is a temporary
Okay,
file
so
space.
if I
Yeah, everything
proceed
else.
Doing some
Yeah.
stuff, loading or whatever, training, or model creating, that will be gone, but I have to
It depends on where you
It
store
depends
it.
where you are staying.
Yeah.
So there is a disk, if you're putting everything in C drive, that will stay with you.
okay.
But if there is a temporary D drive, if you stay there, it might go.
Yeah, you can also attach more drives. So if you know that you need, 4 terabytes of data permanently attached, you can, that's an add-on.
Okay.
But so by default, if you've got, if you can fit it under 40 gigabytes, you can, get it onto.
But the other thing is that if you're not running the deep learning or the training, you really probably don't need the GPU. So you can downgrade it to CPU machine. So that the charge will be really less, like $200 maybe. And just before running your deep learning, you upgrade it to GPU. Run the training, again downgrade it back. So that way it's like a lot of money saving.
Okay, and of course, you need to configure storage.
Yeah.
To
But storage,
yeah,
it's like,
but it's an important step.
Yeah, that's true. So I can show you what that looks like too, so it's not total mystery here. So let me pull up that machine that I already have that I'm not using for this demo. And so I have a disks option over here on the side. I have an option to add a data disk.
Okay.
And so I can choose here, if I had a disk already, I would be able to, so I could maybe move disks between machines if I wanted to. But I'd create a new disk and I have some size options. I think the largest size might be 4 terabytes for a single disk. You can chain them together and make them appear as if they were a single partition. That's fine. So that once this is done, I think there's some setup steps for both Linux and Windows on the VM itself. But then your drive, just as if you were adding a new drive physically on your own machine. And then you've got what you need. So it's a relatively fast process to set up. The disk can be kept around even when the VM is deleted if you want to put it on a new VM later. You can also make backup, store backups of the disk. It's pretty handy.
Thank you.
Oh, sure thing, yep.